Square roots of a complex number. The square roots of a complex number are themselves complex numbers. The following example shows how to find the square roots of a complex number. Find a and b, which are an element of the real number set, if a plus bi squared equals 21 plus 20i, where I squared is equal to minus 1. If a plus bi squared equals 21 plus 20i, then a plus bi will equal the square root of 21 plus 20i. We basically bring the squared over the equal sign and it becomes the square root. So we are being asked to find the square roots of 21 plus 20i. So a plus bi squared equals 21 plus 20i. So we're going to multiply out the a plus bi squared. So a plus bi multiplied by a plus bi will give us a squared plus 2abi plus b squared I squared, and that's still equal to 21 plus 20i. I squared becomes minus 1, so it becomes b squared multiplied by minus 1, which gives us minus b squared. Next, what we're going to do is on the left hand side of the equal sign, put the real parts together and the imaginary parts together. Since a squared and minus b squared don't have an I stuck on, they go in brackets, they become the real part. And plus 2abi is the only term on the left hand side with an I, so that just goes on its own, plus 2abi. Then we have our equals 21 plus 20i. Next we put the real with the real and the imaginary with the imaginary. So a squared minus b squared is going to be equal to 21. The real parts equaling the real parts, that's equation 1. And 2abi is going to be equal to 20i. But we can cancel out the i's, so we have 2ab equals 20. That's going to be equation 2. That's the imaginary parts with the imaginary parts. So we're going to take equation 2 and we're going to solve for b. So we're going to say 20 divided by 2a, we'll get the b in its own, and 20 divided by 2a is going to be 10 over a. Next we're going to take equation 1 and we're going to substitute the b into equation 1. So equation 1 was a squared minus b squared equals 21. So we're going to swap the b for 10 over a. So we get a squared minus 10 over a squared equals 21. So we literally just swapped that b for 10 over a. 10 over a squared is going to give us 100 over a squared, because we square the top, 10 squared is 100, and we square the bottom, a squared is a squared. A squared multiplied by a squared gives us a to the power of 4. Minus 100a squared multiplied by a squared, the a squared will just cancel, leaving us with minus 100. And 21 times a squared is 21a squared. So we just multiplied across the entire line by a squared. Next, we're going to bring everything over to the one side. So a to the power of 4 stays where it is. The 21a squared comes over the equal sign, becomes minus 21a squared. The minus 100 stays on that side, so it doesn't change signs, and this is all equal to 0. Next, we're going to factorize this quadratic. So a to the power of 4 can be broken down as a squared times a squared, so you've got a squared in the front of both brackets. And minus 100 can be broken down as 25 by 4. So we're going to have minus 25 at the end of one of our brackets and plus 4 at the end of the other bracket. And minus 25 plus 4 will give us minus 21. So we let a squared minus 25 equal to 0. So we get a squared equals 25. So a is equal to plus or minus 5. And then we let a squared plus 4 equal to 0. So a squared is equal to minus 4, which is not possible because it said in the question that a and b are elements of the real number set. So we cannot get the square root of a negative number unless we get a complex number. So if it has to be a real number, then this is not possible. So a must be 5, or else a must be minus 5. So now we just have to find the b. So equation 2 told us that b was equal to 10 divided by a. So if a is 5, then 10 divided by 5 is 2. And if a is minus 5, then 10 divided by minus 5 is minus 2. Thus, root 20 plus 20i is equal to 5 plus 2i, or minus 5 minus 2i. So 5 plus 2i, or minus 5 minus 2i, i.e. root 21 plus 20i is equal to plus minus 5 plus 2i.